Direct contact with electricity through a power source, cord, or transmission line is the most common type of electrical hazard and can occur in a number of ways. Fires are a common result of electrical problems. Most often they occur as a result of faulty electrical outlets and old or damaged wiring. Problems with power cords and extension cords, plugs, receptacles, and switches can also cause electrical fires. Explosions are another potential result of an electrical malfunction. An explosion can occur when electricity ignites an explosive mixture of material and air. This can range from a liquid such as gasoline to something as common as dust. Arc flash is one of the most intense forms of electrical hazards. It is the sudden release of electrical energy through the air when a high voltage gap exists and there is a breakdown between conductors. An arc flash gives off thermal radiation, heat, and bright, intense light, both of which can cause burns. Temperatures as high as 35,000 degrees Fahrenheit have been recorded from some arc flashes. High voltage arcs can also produce significant pressure waves by rapidly heating the air and creating a blast.
In our electrical system, for electricity to flow, we really need only two wires. The actual electrons in the wires don't go very far. They just move back and forth, what we call AC, or alternating current. And originally that's all we had. The receptacle had just two identical holes in it. The problem is that by interacting with the surrounding air, the long wires leading back to the generating plant would build up a different form of electricity, called static electricity. This is just a buildup of electrons that aren't going anywhere. The problem was that this buildup of electrons got so great that eventually they'd all of a sudden burst out of receptacles and shock people. Another problem occurred when lightning struck the wires. This would cause a sudden surge of electrons flowing through the wires, which could cause damage to appliances that were plugged in, or even jump out of wires behind walls to shock people nearby. This was all solved by connecting one of the two wires to the earth, or ground as we call it. Electrons no longer built up on the wires, but went to ground instead, and that electrical current from the lightning strikes also went safely to ground.